use the Q&A link that you should see on your Zoom console. Just type your question in there, and we'll get to it at various points during the presentation. Actually, we're going to be covering, I think, the questions mostly at the end. So with that, I'm going to turn it over to Campbell Pride. So Campbell, if you want to come on video, and thank you, and I'll turn it over to you.
All right, thank you, Michelle, and thank you everyone for coming today. Today's presentation, we're going to be covering, can AI reasoning improve accounting estimation? And this is evidence from the Cecil allowance, and we are very lucky to have Ariane Chong here today from Stevens Institute of Technology, who's going to go through the work that they've been doing on the subject and give us a detailed analysis of how they're using AI to improve the results that they've been doing. So I'd like to thank Ariane, and I'd like to thank Kraft and Stevens for sponsoring this event. So with that, I will get it underway and hand it over to you, Ariane.
Great, thank you so much, Campbell and Michelle. So my name is Ariane. I'm Assistant Professor of Accounting at Stevens Institute of Technology. And this project is a work that I have co-worked with Steve Yang and also Shanshan Yang, who is a PhD student at Stevens Institute of Technology. So to give you a little background about this project is that at Stevens, we have a NSF-funded lab that is called CRAP. And we were kind of interested that how these new kind of artificial intelligence, like a development, can be used in the bank industry. And we were trying to actually think about like the applications about these stuffs. And we find out that CISO was recently adopted, not recently, but actually like around like 5 to 6 years now. And so we might actually think that how to think better, like how we can actually use these technologies and try to improve the CISO estimation process. So to give you a little background about CISO, is that during the before the financial crisis, let's say 1980s and 1990s, when the banks were trying to measure the loan losses, the biggest problem about loan loss estimation is that they were kind of over provisioning. So which means that they were having they were overestimating the loan losses and having more kind of expectations of over provisionings. So they were trying to actually reduce this amount of loan loss estimations. But when the financial crisis happened, they figured out that we did it too little and too late. So that was the problem that was raising during the financial crisis about the loan losses. So the regular standard setters like FASB and also ISB, they were thinking about how we can improve this process. And at the first time, FASB and ISB was kind of moving toward similar directions, but FASB eventually adopted what we so called the CISO approach. And then ISB actually came up with a little bit different, like a 3-stage model for these loan loss estimation models. So at this point, after the 2016, ASU 2016-13 was introduced in 2016, 2019 and 2020 was the years when the CISO estimation was in effect. And now we're having like 5 or 6 years of data that how these CISO estimations have been adopted. So to give you a little background about the difference between the previous model, which is the incurred loss model, and the recently adopted CISO model. For incurred loss model, actually the loss was incurred when so-called it was probable. And also these losses were recognized only they were already having evidence of impairment of like a large amount. So you can see that this previous approach was backward-looking kind of approach. And this is like a simple, like a historical loss rate analysis, and it was having a short-term measurement periods. However, the new kind of CISO model is that at day one, now actually the bank should have to recognize the loan losses, so which estimated loan losses, which means that they have to become forward-looking, and then these forecasts should be reasonable and supportable. And of course, that this is a long-term entire life of loan measurement period, and then this should be covering the whole lifetime of the loans. So this is like a more kind of forward-looking model. So in addition to the quantitative approach that the bank will have, they have to make this kind of qualitative adjustment in addition to the quantitative adjustments. So based on our interview with the bank CISO team, is that they actually have adopted like a similar quantitative model, but in addition to that, based on several like events or economic circumstances, they actually come up with, they actually utilize different models and try to estimate how much like a qualitative adjustment that they have to make. So the traditional way that the banks are doing about like the CISA model is that when they have some kind of like a forward-looking like events like that can be affecting the credit losses, the loan losses, then actually they are running different types of like economic models and try to come up with agree upon like a consensus of the adjustments, and then they actually make the adjustment after all, in addition to the quantitative forecast. So this is the difference between those two models, and the way that actually the company have done. I told you that it's like a consensus model, but you can just think that they are in general they are the loss rate method, which means that they're using the historical loss rates of these loans, and they also adopt some like a non-loss rate methods. Basically, they're taking a look on how much like a days that it was not paid. The loan were not paid. That's a rollaway methods, and also taking a look on the probability of the default, and also using the DCF models. So these are the general approach that the industry have. And also in the academics, we have several fabulous papers like which actually look on these types of alternative like a CISA estimation process. Harris et al. Was not actually the CISA model. This was about the using the net charge of. Net charge of, it means that is the money that was not paid minus the recovery amount. So they actually take a look on the net charge of rate and make the 1-year predictions on it. And this was the kind of like a traditional approach that we have in the academics. And then after, we also have several models that take a look on the macroeconomic factors. Like for example, for Lou and Nicola, they actually use the macroeconomic data, and they see some kind of improvement in addition to the Harris model. So we can see that there are several processes that are already adopted, but there are kind of like a regulatory concerns about these types of adjustments that the companies were making. For example, a lot of major banks were having these CISA estimation process to be listed on their critical audit matters on their audit reports. And most of the critical audit matters, the camps that was reported was that the models are complex or it's hard to replicate, or they are very subjective. These kind of stuff were actually addressed by the auditors during the audit procedures. Not only about the auditor side, but also from the SEC were recently issuing like a multiple comments letters about the CISA process, mostly about the transparency, like how much like they disclose about this CISA estimation, or they're transparent, and also if the disclosure is lacking details, SEC were sending out comment letters to the banks. So when we take a look on these kind of concerns, actually the first kind of concern that we have is that the current estimation models does not fully reflect the qualitative adjustments, which means that to make this kind of qualitative adjustments, we have to be more circumstantial. We have to understand events. And actually what the banks are doing is that if there are some kind of events that's going to be affecting these loan environments, then actually that is the one that triggers this kind of adjustments. However, the numeric models that we have seen, it's just based on like the trend or some kind of regressional model. So they could not capture these kind of effects. And also there are no kind of reasoning about this part. So to actually come up with a better kind of adjustment, there should be more reasoning. And actually this is the one that we actually heard from the bank, that which is the challenges of doing this kind of adjustments, because even though they have kind of like a calculated results, they really have to persuade their directors about the the adjustment that they come up with. So they really need some kind of reasoning behind it to come up with this better qualitative adjustments. However, to hire these kind of experts to make this kind of qualitative adjustment is not easy. You have seen that the new CSL model is now requiring like a continuous forward-looking qualitative adjustments. But think about that kind of resource constraint that the bank will have. It will be hard for them to actually do this in a continuous basis, and also based on the boundary rationality constraint, which means that human will have kind of limitations on processing all this information in a like a fast pace, like a following up with those kind of news and events. It might be hard for individuals to perform that. And also the data is out there. There are a lot of like a macroeconomic data out there, but human can have like a limited kind of way to absorb and also process those kind of information. So that is why actually we address some of the challenges that the qualitative adjustments is having the CSAP process. So the first is, of course, the subjectivity when we actually make this kind of estimations. And there are no standard approach to quantify these adjustments. And also, there are no predefined set of qualitative factors that we might actually use for these analysis. Actually, a lot of like academic papers, they use more than 300 different factors. However, we find that the banks are trying to identify probably 5 to 10 most representative factors that can be affecting this CSO estimation. But actually it takes a lot of time for them to actually identify those 5 to 10 factors, and trying to use those measures for adjustment is another challenge that the bank is having. So actually that is why we're coming with our research question here. So our research question is that based on this kind of challenges that the banks are having, we want to utilize the recently developed AI models to estimate the allowances for credit losses, and see that how we can actually augment that to existing models. So, the whole purpose of our project here is not to replace the existing models. We already have seen the benefit and also the strengths of the existing models. For example, the Harris model, and also the loss rate based method, and also non-loss rate methods. They are powerful enough. However, we are trying to actually come up with an alternative method where this AI reasoning can support better decision making for the bank as like a second opinion. And also, we found out the banks are interested about our project because that the things that they are concerned is not is about the like the black swan events. So the regressional models or any kind of econometric models, they are good on getting the trend based on the historical data. However, it is extremely hard to actually predict these kind of black swan events. So that's why actually they're kind of interested that whether these AI reasoning can capture these type of black swan events. So this is our kind of like overview of our research question for developing the AI reasoning model. Okay, I believe that Michelle will give you the CP questions.
Yeah, thanks so much, Aaron. Okay, I'm going to bring up some poll questions for those of you getting CPE credit. And we'll start with our first one here. All right, you should be able to see that on your screen. And the question is, what is the primary difference between the incurred loss model and current expected credit loss, CECL? Is it CECL uses only historical data? CECL recognizes losses only when incurred? CECL requires lifetime expected loss estimation at loan origination, day zero, or CECL eliminates management adjustment, or management judgment rather. So I'm going to give you like another minute and a half on that. And then we'll move on to a second poll question. Okay, I think just another 10 seconds or so here, because I think most people who are getting CPE have responded. Thank you very much for that. Okay, I'm going to close down this poll and let you know that the correct answer was C. CECL requires lifetime expected loss estimation at loan origination day 0. Okay, so let's go on to our second poll question. All right. So the second question is, what is a key requirement when developing CECL estimates? Is it use only internal historical data? Or B, incorporate reasonable and supportable forecasts into the estimates? Or C, eliminate management judgment? Or D, focus only on short-term losses? So which of those best answers the question, what is a key requirement when developing CECL estimates? All right, we'll take another 20 seconds here. All right, we're going to close down this poll. And the correct answer is B, incorporate reasonable and supportable forecasts into the estimates. Okay, with that, I'm going to turn it back over to Ariane, and thank you very much.
Great. Those were tough questions. So yeah, so going back to our discussion, so I told you that we're trying to develop these AI reasoning models that can do better CISO estimation. So when we talk about these AI agents, actually this area is changing so fast. The models that we actually are using are the most updated models. However, I'm a little bit careful to actually strictly define these terminologies. So please kind of excuse me if I'm trying to be a little bit like blurry about the context. First of all, the AI agents, like what we so-called the AI agents, are software tools that are based on the large language models. It could be multimodal language models, or it can be like the basic language models that you are utilizing. And I believe that those who are following the tech news, recently the most kind of like a popular common tool that people, and also including myself, is using the OpenClaw, right? It's actually having a lot of functionality with more authority. However, here in our project, what we so-called AI agents, we're actually not using AI agents, but we're trying to develop the brain of the AI agents, which is the large language model itself, that can improve the NCO predictions. So I'll tell you more detail that how we actually develop this better large language model that can do better NCO predictions. About this AI agentic design is that basically they want to have more kind of autonomous and also task-specific kind of agentic design. And also they want it to be more reactive in adaptations. So what we're doing at this point is that we're developing that large language model, the brain of the AI agents. And actually you can use this AI agents for all different kind of purposes. So that is why we made this agent with a very lightweight model. And it can be even installed on your cell phone. Is that kind of like models, and also it can use for all different purposes. And actually, we believe that we can make it more stronger with stronger models. However, we find that it is enough to make this NCO prediction. So that is why that will be the one that we're going to show you. When we're actually trying to develop these models and also the AI agents, actually there are several challenges. So the first biggest challenges is that it's very hard to make the agents to be the large language model itself to be very task specific. So our task is making NCO predictions. So to do that, actually you cannot just use the raw model. You cannot use a raw model to run this NCO predictions. So you have to somehow fine-tune the model to make the better predictions. However, when we actually train this model, there is a big issue that we might be like overtraining the model, which means that it might be overreacting. So basically, the model is not making a more conservative kind of answers or predictions on the NCO. It is kind of overreacting on it. So that can be the cases of the model, and this is the one of the out of order distribution error that the models can have, including the hallucination. So that is why, to address these kind of challenges, actually we adopted the group relative policy optimization approach. So this approach is one way that we can reinforce the model. When I say reinforcing the model, is that we're actually starting with the existing large language model. However, we are actually fine-tuning it to actually have this model to make better the NCO predictions. So we're actually hard training the model millions of times with hundreds of iterations to actually make the model to learn the process better. So you can just think that we're actually training a fresh undergraduate into a NCO expert, but we're kind of expediting that part, actually using the reinforcement method and doing millions of times of training of the models. So you can just think that a human expert is actually predicting the NCO, learning why it was wrong, and then going back and then making the prediction again, and trying to learn that what is the mechanism behind these predictions with the given data. So for GRPO, the reason that why this is kind of outperforming compared to other reinforcement method is that actually what it does is that it comes with the rubric, and then actually it asks the model to create multiple prompts, and then based on the prompts, actually it grades the prompts based on the rubric, which is created by human, and then after it actually makes the models to come up with the most best answer next time. So it's just creating the mathematical connections to have a better answers next time. You can just easily think that when you use ChatGPT, it will ask you which answer do you more prefer, right? So ChatGPT is learning this from millions of people, and also this is similar when you use Netflix. If you watch a one movie and you really enjoy it, Netflix will ask you, maybe you might also like this, and then you choose one of those movies. Then actually the machine learning model behind Netflix will learn that this person is having this kind of preferences more. So this is kind of like a reinforcement fine-tuning method. So here, what we're doing is that we are having the data, and based on the rolling window, our data prediction is based on quarterly level. We use that NCO and also macroeconomic and bank level data sets from the call reports, and then we actually pre-process that data, and then we put that information into a prompt. We call these the information that we put as a features, because we don't put all 300 a macroeconomic data. We actually pick up the most relevant one to to each bank, and then we have the model to learn it and make the qualitative adjustments. And meanwhile, actually, we do this. Also, we have the baseline model that I introduced, which was developed by other academics and also the industry practice. We actually utilize those models, and then we plug in our adjustment factors into this model, and then we actually see that whether it outperforms the existing models. So this is the approach that is in a macro level that what we conduct. We use 1,196 bank information in a quarterly level from 2001 to 2025. We didn't exclude the COVID period and financial crisis period because we also want to see how the models are reacting during the Black Swan events. And also we are using two different types of data sets here, blank level variables and also macroeconomic variables. So some of the examples of bank level variables will be the current NCO rate, non-performing loans, average loan yields, and macroeconomic variables will be unemployment rate, inflation rate, GDP growth rate, and CPI. The reason that why we're utilizing these data sets is that for our paper, we're focusing on the credit card loans. So that is why we're utilizing these specific list of variables. And then I told you that we're not using all hundreds of economic variables. So what we do is we use a feature selection method. which means that we're using a decision tree. Decision tree is a supervised machine learning model where it can actually, which is used for classification purposes. So actually, we use this kind of like a decision tree model to actually see that what is the most features that is affecting are correlated with the NCO rate, the future NCO rate. I will be a little bit careful with correlation because it's not exactly correlation. It's about how much it actually contributes to the prediction of the future NCO rate. And then we select the most important features, not putting all these like variables. We actually capturing these. And also this aligns with the bank's practice where they're actually focusing on the most representative features for each economic events. And then after we actually use this once for our estimation. So the model that we use is QN3, 1.7 billion. It's because that was the kind of like the relatively light model. And also that was the this is the multi-language model. So we thought it might be good to actually use. And the first step is that we set several parameters. These are just like machine learning. Sorry, some technique details that we actually puts for the initializations of the training process. And then we build a reinforcement learning environment, actually creating the prompt that the large language model can understand. So for this part, we have to put the data set into this prompt. So we actually put the selected data set here. You can see that there's a bank level features, macroeconomic features that we put in, and then we give the task, and then we give the requirements of these predictions. And then we also give a output format that the large language model should have to provide us with this predicted results. Okay, so for the predictions results, actually, it will give us the actual value of the NCO rate that is predicted, and also the interval where the large language model is at, which is the lower limit and upper limit of the prediction interval. And then also we put some of the key drivers of it, and also the confidence level the large language model can provide us. And then actually, when we put this to the large language model, it will give us this answer. So giving following the format that we suggested, it will actually provide us this part. But as you can use actually ChatGPT, it will not give you all like every time the same answer. It will somehow give you some different answers, right? That is actually a problem for us because we want to make a more accurate predictions of it, and also format actually matters for us as well. So to actually make this models to better predict the results and come up with a consistent like a formats and also have better accuracy, we actually are using the GRPO approach here. So the GRPO approach, I told you that it actually asks the models multiple times and get the prompts. So it gets for our model, it's getting 8 answers. It's getting 8 answers with slight randomness. Actually, we actually give a little bit different seed numbers when we ask the large language models, and then get 8 answers. And then after, actually, we grade the answers that is given by the models based on these based on this reward function with specific weights on each factors. So the first thing is the accuracy, how well this model is predicting the net charge-off prediction. And then after, we're seeing how much well it is being in the confidence interval. And then also the third one is that we're seeing that how the format is matching well with our expectation. So we take a look on whether the titles are existing with our suggested titles, and then having every information and having all the units correctly. These are the things that we grade when we get this each prompts. So whenever we're getting the prompt, you can just imagine that the freshly college graduate analyst is actually giving this to the his senior or his or her senior, and then getting it graded. So we grade all these prompt, 8 prompt, and we choose the best one. And then we actually make the model to come up with a similar answer with that prompts based on the dynamics it learns. And actually, we find out that the confidence interval and also reasoning quality is pretty much easy for the models to learn. But the problem was accuracy. We're still actually struggling with this part because actually the reason that why we find recently is that most of these NCO rates are close to 0%. So that is why the accuracy is like a little bit zigzagging in different types of time periods. But you can see that the interval rewards, the confidence interval and formal rewards are actually doing well in conversion. Conversion is actually really important for machine learning. You can see that here, the interval rewards are getting close to 1. 1 is the maximum, and -1 is the minimum for this interval reward. So you can see that after actually 50 rounds of training, it actually really goes closely to that number and converges. And then also for training for the format, actually the large language model is following well. And actually we see that the accuracy is already like close to 0.8, but we're trying to actually make it better converging at this point. So for this part, when we actually use this this type of different types of using this reward function, we came up with the best answers. And then we, based on this, actually, we prioritize the best responses with the grading parts. And then we actually train the model to come up with those answers better and updating the model parameters. The model parameters is basically making the large language model to come up with the next word or the paragraph itself, the context to be more aligning well with the best answer that we got. So this is the way that actually the large language models is basically like predicting based on the probability, basically the likelihood of the next word that will come up in the context. And then after we train this model, we test this with the auto sample. Auto sample is the unseen data set that we use for testing purposes. And then we check this, we save this checkpoints and repeat this millions of times, and trying to see that for this, how we will actually estimate. We're using, I believe that was H200 for this training process, which is a very strong GPU. And we actually run this like weeks to actually come up with the answers. To give you a little bit kind of back, the model performance that we have and the insight that we have learned. First of all, you can see that these are the error rate. So there are two different error rates. You can just think that MSE, it is actually better. If you have a lower MSE, it means that it is well for the extreme cases, like the black swan events and things. And MAE, these are like in general, how well actually the model runs. So for this part, this is the first part, LLM pre-train is the one that is not trained. And then the second part is the tune one, fine-tune, the one that actually introduced. And I told you that it's better to have a lower number for this. And for this part, we actually find out that this for including extreme cases, plus for T+1 and T+2, actually the large language model that we train outperforms. We also see that it outperforms for T+4 and T+5, but we want to be a little bit conservative. We want to actually cut off the benefit of our model until T+2, because that every result that we got is actually better until the T+2 period. And actually, this aligns with the conversation that we have with the banks. Actually, we heard that it's very hard for them to make the predictions above T+2, which means that half-year period, because a lot of events can happen during that period. So also their practice is pretty much predicting the next quarter. They don't really make this kind of long-term predictions on the qualitative adjustments oftenly, but they try to make this part every quarter adjustments to make the estimations to be more relevant and timely. And also for MAE, we saw that there is a huge decrease on the MAE for the T+1 and T+2 period. We also actually compared this with the existing model. I told you that it's better if that is having a lower amount. And this is our model, LLM GRP or tune. This is our model. And HKN is the existing estimation model. And expanded HKN, this is the one that was using macroeconomic data as a suggestion for a CISO approach. And you can see that our approach is not well performing than the HKN, the existing model. However, it is better using the macroeconomic data with the regressional model. So here you can see that the large language model is not that like exactly powerful as the regression model. However, when we include the macroeconomic data, then actually this large language model is much more powerful than the regression approach that we have. So we actually told you that we're not competing with the regression model, which actually does not use the macroeconomic data, using the trend analysis with the historical data. Using the historical data is very, very strong. It can explain a lot of like trends and the increase and decrease of these measures. However, we're trying to say that these large language models are giving benefit in addition to that, in addition to the regression model. So you can see that this model is much better than the regressional model that use the same macroeconomic data we use, also from the MAE approach. And for MAE, actually, when we exclude the exceptional cases, you can see that it is pretty much kind of similar to the regressional model that we can see. And before I give you the last results that actually for this presentation, is that as you can see that a lot of results, NCO rates, actual NCO rates are close to zero, right? You can see that's very, very close to zero. And there are some cases that is above zero. The reason that I'm trying to show you this one is that actually I told you that we also want to see that how much it gives incremental contribution in addition to the existing model. This is the percentage of MSE improvement, which means MSE reduction, error rate reduction. You can see that it's having a reduction for every time period. This is the one that you have to focus on. And numeric factor is that we're actually making the adjustment with like very hard adjustment with the actual number that large language model gave. And actually it is known that these large language models are not really good for number predictions. You can just think that you will not ask the probability of like a rain forecast in ChatGPT. You will just try to take a look on the weather forecast, right? But even though actually it is hard to make that, we see that there are several improvements with the numeric factors, but we see that if we actually put the directional prediction, whether it will increase or decrease compared to the existing HKM model, actually it all outperforms. This number 1.6% is because that I told you that most of them are centered around 0%, so that is why it is having a lower amount of percentage. However, if we go to MAE, in average, actually you can see that it's having much more improvement with the rho for our model. And then we actually compare with the existing Caesar estimation model, then you can see that we're having much more higher percentage increase of the model. Since actually I'm almost out of time, let me just give you just one kind of slide that showing that we actually figure out the reason behind this kind of improvement is that this actually graph shows the how much these answers that is coming from the large language models are actually forward-looking. That is the features that we want to actually see from the models, and then how much also they are specific. They are forward-looking, but also very specific. The models that on the lower part here, you can see that these are the one that when we use the pre-trained model, no train. The one that you can see above is that the one that which based on our fine-tuned model. You can see that they are not having these like tails anymore. They're being in the head of the in the middle of these in these distributions. So which means that they are actually coming with very similar answers, but they are forward-looking and very specific answers. So this is like a one kind of exploratory analysis that we have done to try to understand why we are having better answers by using these models. Kind of like a takeaways about this part is that we find out that AI models can be used for reasoning, but we cannot just use it as it is. Actually, it really needs a lot of human intervention in the loop. We call this HITL, human in the loop process. So for us, actually, the way that we learn, actually, we have to be careful with two different parts when we actually use these large language models. First of all, you have to carefully come up with the metrics, the rubric that I show you, the reward function. We have tried with a lot of different types of factors, and to come up with the better answers based on our practice, we actually learned that we have to carefully tailor those factors and also those weights. You have seen that now we're actually giving more weights on the accuracy because the models were not learning well from the accuracy side. So it's like playing a violin. You have to actually really play around with these numbers to come up with the better answers. And then we also figure out the second part is that you have to be careful with the what we so-called the KL penalty. KL penalty means that we're trying to actually come up with the answer which are not very different from the original answer that we will have. So we're not trying to make the machines to be so like extreme. I told you that in the beginning of this presentation, like overreacting and trying to mitigate that part, but still having like a performance benefit by this training. And still, we find that the long-term predictions are pretty hard. It might be because of that these models doesn't have updated information. Maybe that might be why. But actually, we find that for long-term predictions, consistently, the results are not that much better than the pre-trained models. But in the short term, T+1 to T+2, some T+3, three-quarter predictions, the model was outperforming almost like a 30 to 40% compared to the pre-trained models. So for the next steps, actually, we're still trying to improve the model. We're trying to improve the model with the accuracy side, and we want to use this brain. We want to use this brain with giving them different roles. And at the end, we're trying to actually make the banks to use this our tool as their second opinion, like a provider when they do CISO estimation. So as a conclusion, actually, we operationalize this process to make these adjustments. And for the academic and also the industry audience, we're trying to give that what we learned, what was the challenges, and what kind of stuff that the practitioners have to go through to make these estimations to be realizable. Yeah, that was my end of my presentation. And then your test is waiting for you.
Great, Ariane, thank you very much. Yeah, we're going to take a couple of CPE questions, and then we will go to our audience questions, and I'll be turning it over to Campbell then for audience questions. So let me first go to our next CPE, and you should be able to see this up on your screen. What is the purpose of qualitative adjustments? Is it 1, to replace quantitative models? Is it 2, to adjust for factors not captured in quantitative models? 3, eliminate uncertainty, or 4, standardize all estimates? So let's take another 30, 40 seconds here to respond to that, and then we'll go to our next question. And just a reminder is if you do have questions for Ariane, please post them in the Q&A link that you see on your Zoom platform. And we'll be taking those in just a minute or two here. Okay, so I'm going to close down this poll and go to our next poll. And the appropriate answer to that one is B, adjust for factors not captured in quantitative models. Okay, so let's go to our next poll. Okay, you should be able to see this on your screen now. What does group relative policy optimization, or GRPO, refer to in this framework? And the proposed answer, the potential answers are a regression-based optimization method, a deterministic rule-based checklist, a reinforcement learning method based on reward functions, or a data pre-processing technique. Which of those answers is most appropriate in referring to GRPO? And we have about another 20 seconds here. Okay, I'm going to close down the poll in just a second here. And the correct answer for that is a reinforcement learning method based on reward functions. So now we'll go to our last poll. And the question is, which of the following is an example of a qualitative factor considered under CECL? Is it macroeconomic conditions, lending policies, portfolio decomposition, or is it all of the above? Okay, we've got another 40 seconds here. All right, another 15 seconds. All right, I'm going to close down the poll. And the correct answer to that question is D, all of the above. So thank you very much, everyone, for responding to that. Campbell, I'm going to ask you to put on your camera and come back and take our questions. Thank you.
All right. Thank you, Michelle. All right. We've got a couple of questions here. And so it's kind of there's two questions that we've had from the audience, but I'll kind of make them into one. And this is from Brian Crowley. So the question was, are you actually fine-tuning a frontier LLM or are you fine-tuning a prompt? And then it's got prompts or a skills markdown file and Anthropic or similar framework. So that's kind of the first question. And I'll give you the second one kind of at the same time. I want to answer at the same time. Or is the thing an auto machine learning agent that you can embed in a traditional machine learning workflow?
Right. Just to make the audience to be familiar about these kind of terms is that auto ML is it's like a tool that you use to develop machine learning models and actually optimize the models for you. And what we so-called the frontier large language model, you can just think that it is the brain that make this large language model use. If you use ChatGPT, you can actually choose different models, right? You can choose GPT 5.4, you can choose GPT like a 4.0 mini models. So what we're doing is that we're actually training that model, GPT 5.4, this kind of model, but the model we're actually training is smaller. It's called the QN3, QN3 1.7 billion models. Even though we use that model, it needs a great computations. That is what we called the frontier large language model, which is the brain of the model. Yeah, we're not fine tuning the prompt or I think that you mentioned about the skills on the existing models. No, that's not the part that we're working on. We're working on the model itself.
All right, thank you. Aaron, I have another question is, what would you tell an auditor who was going to audit the CECL estimate, and if the auditee or the bank was to come back and say, well, look, we've used a large language model along this type of framework to basically make our estimate. If I was the auditor then reviewing that, what would be the things in that model that I should look for to see that the results make sense?
So the key practice that the auditor does when they actually audit the CECL part is that they use they actually recalculate that based on their models. They will also reperform it. However, they actually conduct the estimations with their existing models as well. But actually, when we're talking with the banks, the most concern that they have about this model is that this cannot be the frontier model for them, because this is like a one part of the one model that we have. And actually, that is what the banks are already doing. When there is some kind of event that is triggered, they're actually having several models and they're trying to find out the consensus among those models. And we hope that our model can be one of them that can actually improve their consensus. So as an auditor, I believe that they have to take a look on whether these models were having consensus with the other existing models. And if they're having kind of deviation with the existing model, I'm pretty sure that they have to document this process, why it was actually deviating, and finding out those reasons. So we hope that our models can be a kind of like alerting model that the regressional models cannot find. So if the firms can identify those kind of part with our models and adjusting their parts of the estimations, I believe that the auditors might have to check that the reasons behind it and what kind of other supporting evidence they find from our alerting large language model estimation.
And so do you think it would be feasible for audit firms to have their own models as well?
Well, I think so. I'm not sure whether they are using similar models that we are actually developing. I'm pretty sure that they're using the similar approach that we do with the CISO estimation with the traditional approach. I really believe that they should have a model like us that can identify these type of events that cannot be captured through the regressions.
Right. Michelle, I think that's all the questions we had, so maybe I can hand it back to you.
Great. Thanks very much, Campbell. Well, I want to thank everybody for joining us today, and thank you very much, Ariane. It was a great presentation, really interesting work that you've been doing. I also wanted to mention to our audience that we have an event coming up on May 15th, and it's called AI and Structured Data Forum, Optimizing Performance. It's a one-day program. It's going to take place in Hoboken, New Jersey. It's being held at Stevens Institute of Technology in partnership with CRAFT, which is an organization that focuses on topics such as decentralized finance, artificial intelligence, and lots of other interesting topics. There's going to be a session on AI, audit, and assurance, and you can see here on the screen the speakers that are planned to be in that program. We have another session on interoperability in decentralized finance, and we're going to have a keynote address from Julie Marlowe from the Office of Structured Disclosure at the U.S. Securities and Exchange Commission. So please join us for that event. We'll be sending out information about that to everyone with the follow-up and the replay for this program, and we hope to see you there. So thanks again, and we'll see you at our next webinar. And if not, we'll see you May 15th. Okay, thank you.
Okay.
Thank you, everyone.
Bye.